So, hello. I guess the camera's not here. Hello, good morning, good afternoon, good evening. Thanks for joining us for the episode of the podcast at Delphi.org. I'm your host, Jim McKeith. Joining me today, let's see if I point direction this direction. Yes, I got it right. Down there is Craig Chapman, our software consultant down in Austin, Texas. And unfortunately, David Millington, even though he is on the best Wi-Fi in the world, best broadband in the world in Estonia, was getting lost packets, and so he's not with us today. Okay, so looks like we're all good. I'm going to switch some things around here since we just lost David. Let's go.
I'm going to make me bigger, are you?
Yes, you're huge now. So, you know the song Big in Japan? Mm-hmm. When I was in Japan, when I'm getting to the hotel and checking into the hotel, this young lady that's helping me check in, she goes, "You very big." It's like, it's official, I'm big in Japan.
Excellent.
So I have got a new, working on here, a blue screen. It's actually reversible. It's blue screen on one side, green screen on the other. So hopefully I'll get some lights on this, and I guess it needs to be higher or closer. I'm working on that. But the idea is that it'll be blue screen, and so you'll just see me and then the part behind me, instead of seeing my cluttered office here, will be transparent, so you could then see the desktop that I'm sharing or whatever.
That's a pretty cool plan.
Yeah.
Wouldn't mind setting something like that up myself, back here. I've been, recently, just when I enter my gameplay, I've been streaming it. And what I'd quite like to do, because I'm playing Elite Dangerous, which is a spaceflight sim, I'd quite like to stream myself with the inside of my ship projected behind me. So it looks like I'm sat in the cockpit. That would be kind of fun.
That would be cool. Alright, so now it's just the two of us. Maybe I'll wriggle it around a little bit. So today, at least wanted to talk about single board computers. And I did not get all of my single board computers. I might have to dig for them, because some of them are in various locations here. But I thought I would go through and show some of these off and talk about the pros and cons of them. So, let's see, I need to... I thought this could mask. That's really weird. I'll have to figure that out. I need to figure out how to make my... crop in the video so it's not as wide, because I just want a portrait, but we'll figure that out. Let's go ahead and make this bigger for now, and go from there. So I did get a couple other things here. I'm working on upping my streaming game. I got this guy here. It's a Stream Deck.
Oh, hello. That's a fun-looking thing.
Yeah. So it's a these are programmable keys here with little displays on them, and so the idea is that I can hit buttons on this, and it can change the screens or the layouts. So in OBS, you can have multiple layouts, multiple scenes. And so you can hit a button here to change scenes, or you can hit a button to tweet on Twitter, or hit a button to go to a web page, or change system hotkeys, or do really anything. Basically, it's like a programmable keyboard control.
But it has cool glowing LEDs, which makes it cooler than most keyboards, right?
Exactly, exactly. Because you can, each keyboard's a little display. So and it came with a nice little sticker here too.
Oh, that's fun.
Yeah. Elgato. I also have, and I can't show it, but it's not working yet, is a hardware streaming device. So everything goes to the monitor here. You see this monitor here.
Okay.
That I'm mostly covering up. Mm-hmm. So it's just kind of... I've moved the mouse over. This part here is being streamed in hardware. So everything that goes to that monitor being encoded. Encoded in hardware, so that I don't have to encode it on the poor Mac computer, since it gets overloaded and starts crying. So that way I could not slow my computer down as much, because as David pointed out last week, when he's streaming or when he's recording video, it slows down the whole system quite a bit. So hopefully that will prevent that. Okay, so let's talk about single board computers.
All right, this is something I don't know a huge amount about, but I take it you've got plenty to show us.
I do. So this guy here,
And a Pi?
it's not a Pi. So there's two different sets of single board computers you're going to run into. There is the Pi clones and the Arduino clones, right? Or the Pi compatible and Arduino compatible, really. So this one, I want to make sure I got this right. I remembered it being more obvious than this. I'm pretty sure this one is my this is the BeagleBone Black.
Oh, so
Okay.
that's a droid.
Yeah, so this one runs Android. It'll run Linux as well, but it's got an ARM processor. So if you're wanting to do run Delphi on it, you're going to want to install Android. So they do have, and I'll bring up the website here. BeagleBone Black. I don't want this on that screen. Can I get rid of that? Oh, good. There it is. So, BeagleBone Black. Let's see. Where's the software? Getting started. Discussion. Accessories. Somewhere they have their own Android distribution you can download from here, as well as all the pins and such. Software compatibility, Android. So interestingly, it's designed to be compatible with the Raspberry Pi, but the Raspberry Pi doesn't have its own Android distribution. Interestingly, which there are ones out there that work on it, sort of. And that's what I found is that while the Raspberry Pi is kind of the gold standard, if you will, because it's a lot of the other alternatives are more specialized and actually probably a better solution for specific situations. Okay.
That's right, Pi's Linux out of the box, isn't it?
It is BeagleBone Black.
Or I say nothing out of the box, actually. I think you have to install Raspbian on it or something like that.
All right, let me just Google it. BeagleBone Black Android install. Oh, come on. I was on here earlier and saw it. I don't know if I'm just getting where I can't remember things or if things are actually changing around more than
Well,
that's what it seems like.
Did you not have a birthday recently?
Oh, be quiet.
Maybe it's the remembering things, Jim.
Latest software images. There it is. Black. BeagleBone Black. Okay. Android. I'm not seeing it. Okay. Oh, I need to make the camera smaller. Oops. That's the wrong thing. Alright. And somewhere on here, I know I saw it and I've downloaded it, but they have you can download the Android BeagleBone Black Android install. Isn't that what I just Googled? That's a book. Okay, there it is. BBB Android. It's KitKat 4. So that's kind of older now. I remember when that was new. Anyway, so there is a BeagleBone Black's probably an older board, but there is a official Android image that you can download for it. Now, I do have a Raspberry Pi as well, and it's in this cool Raspberry Pi case.
Mm-hmm. I like that you have all of these in cases.
Some of them I do, some of them I don't have cases for. So this one, it's Linux by default. So really, if you're wanting to use this one, I've got an Android. Well, they have a couple official, official. What's the term I'm looking for?
Distros?
Oh, here, distros. Yes, of Linux, Raspbian, and let's do this. Send live. Okay. That's not it. I'm rearranging my screen here. Soon's alive. Okay. They have a couple official distros for this that are Linux, but not Android. Raspbian, and then I can't remember what the other one's called. I should know this. But anyway, so if you're going to use this one, what you can do is you can actually do run something in you can't develop for this directly with Delphi, but once you have something on here, you can certainly talk to it from Delphi, whether it be via a REST service or Serial or something along those lines.
Is that because it's an ARM processor in there?
Right. So this one's an ARM processor,
So it's
just
Linux
like the
ARM?
BeagleBone.
Right.
Yeah, both of these are ARM, which means if you want to target it from Delphi, it has to be running Android. Now, you can run Android on this Raspberry Pi, but it's not a very good experience, in my opinion. You can, technically, and there are a couple people that will sell you a nice Android built for this, but it just isn't quite there yet, which I'm not sure why it's complicated to make it work correctly, but apparently it is. So, Raspberry Pi. Okay.
Did you not tell me recently about a board which is Raspberry Pi compatible but Intel?
There is, and that's what I was just looking for, but I'm not seeing it. What's right here? One of my projects is I'm working on organizing my office, which sometimes means I move things and forget where I put them. Okay, usually that's what it means. Where did that go? Alright, here's one. Oh wait, nope, that's not it. That's the screen for it. What the heck? Okay, no more birthday jokes, Craig. Well, I got this one. It's not. It's the case is closed. This one is. Page for it. Netgate. Solutions. Oh gosh, what was this guy? Netgate MBT.
I just heard a noise outside. We may be about to start getting interference from gardeners.
Okay, so they make this one's. I don't think that's that one. They have these computers, maker boards and kits. There we go. The Minnow board. So these are. This is a maker board. So this is just in a case for it that comes pre-installed with the case. And then this one has, I got the model with 2 Ethernet ports on it just because, why not, right? These are, they're not Raspberry Pi compatible, but they are single board computers. This one's in a little case here as well, but it only has the single Ethernet port. But what they have, they do have the GPIO pins here, general purpose IO pins.
Right.
And they also have accessory boards you can attach to them as well. So these guys are building these computers or selling these computers, kind of targeting the idea of having, so you can build your own network appliances, if you will. Mm-hmm. So there are these here called lures, right there. Lures. Lures are designed to be connected to these things on the board. And so this case will open up and I can put a lure in here.
So they're your shields?
Yeah, they're essentially shields, exactly. Specifically designed for this. So they have like a GPS lure and a atomic clock lure or something like that. Right. So there's one of their standard ones. So yeah, so these are x86 computers, just single board x86 computers. So You can run Windows 10 on here or ARM. I think. Wait, I'm not sure if these run Windows 10, but these you would run x86 64-bit Linux on, and you could target from Delphi that way.
Right. Look like the coolest ones for working with Delphi so far.
So I do have. So occasionally I do have kids that come in here, and things have been known to move around. And even if they're not the ones doing it, I will blame them. I'm gonna go bonkers here. What the heck? All right, hold on a second. I'm going to step behind my screen. So, Craig, do something entertaining while I'm gone.
Okay. I love being put on the spot like that. Hi. Let's see if we can hear Jim cussing behind the screen. If he's gone too much longer, I could play Tetris, I guess. Alright, there we go. This is boredom alleviation right here. Let's hope he comes back soon. Still not back yet? Ah, you're back.
Okay. Craig, were you talking about something Delphi related?
No, I was playing Tetris.
I mean, entertaining for everybody else, not for you.
Oh, whoops.
All right, so I only found one of them. I'm not sure. I went through and gathered both of these and put them together so that I would have them. And now I don't see it, so it's probably hiding in plain sight. Luckily, I have a patient wife that puts up with my... Oh, there it is. Puts up with my obsession about collecting these things. Okay, so this is the LattePanda, and I've got the heat sinks on it here, and an active cooler on the back. So let me bring up the webpage for this guy here. So this one's actually pretty cool. And they just have a new Kickstarter they just launched for the Ultra version of it. Let me do this and make this smaller. Okay. So, I can't remember which particular model I have, but this will give you the general idea of it here. It is so it's a Windows 10 computer. You can get these pre-installed with Windows 10 activated, okay? and it has the GPIO pins right here, which on mine I've attached these this ribbon cable to so that I can get to it while the case is on.
Right.
Because, you know, I have a case on it.
So these are a little bit more pricey with Windows pre-activated, or I mean, is it an embedded or full edition?
It's full edition Windows 10. This is a full Windows 10 computer. So, in the world? Okay, so the pricing here, if you go for, so here's Windows 10 activated. Let's see if they have the price tag on here. Oh, shop now. Windows 10 Home Edition. And they have, it's a special download you can get from them, so you can download it from them with, oh, this has got enterprise license on it. And that one there. Windows. So the base one here is $120. And then and I got the acrylic case. But wow, this case was a pain in the keister to put together. I could not believe it probably took me an hour because it's got all these little pieces and parts. It comes, you know, in flat sheets of acrylic. You got to punch them out and put them together, and it's just like, you know, inserts. It's like a piece of furniture from IKEA. It was really bad. So here we go. This one, okay, so this is the 4 gig, 64 gig, 4 gigs of RAM, 64 gigs of onboard storage with the enterprise license. So this is $200 with the enterprise Windows license. Sorry, not Linux.
I like watching, there's a guy by the name of Ben Heck, does a YouTube channel. I like watching him when he's working with these single board computers. He prints all his own cases using a 3D printer. It's kind of fun to watch because he'll print, you know, 2 halves, but he'll put the relevant sort of razors for the screw holes and everything, so you can just screw 2 halves together and you've got a case.
So what I hear you saying is I need to get a 3D printer. Yes!
You do need to get a 3D printer, Jim. I need to get one as well.
So this is the base one here. It's $89. Does the Windows unactivated on here, whereas the other one here that's this one has Windows
new edition.
Windows activated. So you're paying an extra $20 to get Windows 10 activated.
That kind of makes sense, I guess. They've got some kind of OEM deal going on there.
Yep. But so one of the things that's cool about this one is there's 2 sets of pins on here. Which, see if you can see that here. You have these pins here and these pins up here that have the ribbons attached to.
Right.
Now, these pins here that have the ribbons attached to, this is an onboard Arduino. So there's a separate Arduino on here, Leonardo, I believe is what it is, that runs separately from the Windows 10 computer. These pins down here, this is not mirrored, so I keep getting confused. These pins down here are GPIOs to the Intel processor.
Right.
Okay. So you have two sides to this. You have the Arduino is running separately from the Windows 10 instance, and actually I think you can run the Arduino with the Windows 10 system powered down. All right. So you have a dedicated serial connection between the two, so you can talk to it. But so if you're wanting to build a system that talks to an Arduino or uses an Arduino and then can use any of the Arduino compatible hardware that's out there, which is a ton of it, then this is the way to go. So I've installed Visuino on here under Windows 10, and it works swimmingly. You just run Visuino. You could actually install Delphi on here, although it's not the most powerful Windows 10 computer, so I wouldn't recommend it. But you can, deploy your Delphi applications on here, and then connect to the Arduino.
You could always just put the PA server on there and then deploy through that.
Yep, exactly. So that's what I've done. This one does have Wi-Fi on it, so if you see this little loop of wire here, see that? You can see that's the antenna there, so you could mount that outside of it. It's got Ethernet on it. Oops, Ethernet here. There's an audio jack, micro SD card, and power. Oops, come on. Audio jack, micro SD card, power. The micro SD card is for additional expansion. It has 64 gigs, or this one has 64 gigs. They come with either 32 or 64 gigs of built-in data storage. And on the reverse side, we have the two USB 2 ports, a USB 3 port, and a HDMI port. And let's see, on top there is a, where's it at? Right there is a, this button right here is the power or the reset button.
Excellent.
That's the LattePanda. So this is if you're wanting to run Windows 10 on a single board computer and that has a built-in Arduino, this is probably the one I would recommend here. The other one, which I finally found, is the Udo x86. Oh, actually, so LattePanda, I mentioned this. They do have. Let's see if there's a link here on the homepage.
Got a question here about what projects you plan to use these machines for.
Ultra. Take Over the World is generally all my projects involve that.
Take over the world. If you're anything
Yes.
like me, you have projects which are an idea that came to you. You ordered a board for it. You put the board into a box or a drawer, and then you forgot about that project to move on to the next one.
Yes, exactly. Okay, so this Kickstarter is over here. This is the new one, the Alpha, which is they're really taking it and ratcheted it up a little bit. So this has got a full Core M3 processor, which is the same thing you find in your MacBooks. Much more powerful system. So it was funded a while ago, and estimated delivery, let's see, May 2018 is when they expect to start shipping these. So my experience on most Kickstarters is either they hit this date or they're off by 2 years.
There was a device, and I want to say it was a Nook, but the Nook's an e-reader, isn't it? There was a device at CES which was a very small form factor computer with a full, I think it was a full i7, or maybe it was a Threadripper. And yeah, it would have been no, it was an Intel chip, that was it. So it was an Intel chip and an AMD graphics hardware all integrated into a single piece of silicon. And this thing could outperform, I mean, looking at the specs, it would outperform my desktop quite easily.
Wow, really?
Yeah, I mean, half the case was heatsink. So I'm going to see if I can look that up, because I think if you had a device like that, it's not much bigger than the devices you're picking up here. But this was a ridiculously powerful machine for the form factor. I'm going to Google around and see if I can look that up. It's not released until later this year. But I'll see if I can find that and dig it out and share with you.
Okay, so this is the Udo, their page here. All right. This is the Udo x86 Ultra, which I think that's the model I have. Let me go ahead and unwrap it here.
It was Nook NUC. It's the Hades Canyon Nook, which is an Intel CPU with AMD graphics integrated.
NUC, what's it called?
It's an NUC. It's Hades Canyon. Let me paste this in your chat window here so you can Google it up. And this is it's a small PC. It's actually capable of VR gaming, which is one of the first things that comes up when you Google for it. It's not as inexpensive as some of these single board computers. We're closer to $1,000, but
oh wow, yeah.
Give you a link here. This is this really impressed me for
There it is.
the size.
This is their homepage.
Yes, so if you want something staggeringly capable, that's an
Six
i7.
4K displays. Dang.
Yeah, that's an i7 Kaby Lake processor with Radeon Vega 24 compute unit graphics. This thing is just staggering for the form factor, and
Yeah.
like I said, most of that, if you look at the image of it, most of that at the back where you've got those vents, it's all heatsink under there. So,
all heatsink under there, yeah.
And all of that heatsink is for this tiny little integrated chip, which includes the Intel and the AMD on one piece of silicon or one substrate, I think it is.
I heard about this. I need to apparently switch my camera so that... Let's do that. I'm looking to the left. My thing's on the right. There we go. Let's do this. Ta-da! Now it looks like I'm looking at it. Although you're on the wrong side.
Right.
Fix that. Oops. Craig. There we go. Send to live. All right. So I remember hearing about some of these systems that were going to be the Intel, the x86 CPUs with the integrated graphics, which improves their performance because you don't have to go through the system bus then because it's right there on the same chip.
Yeah, you actually have integrated PCIe lanes on that.
Yeah, exactly.
Yeah.
So this has the... that's what they've been doing on the ARM side for the mobile devices is the system on a chip, is what they call it. And so you have the processor and everything.
Intel have been doing this with their Intel integrated graphics, but Intel's integrated graphics just don't compare with AMD and NVIDIA chips. So they've clearly partnered to get that out.
Well, here we go. I can get one for $800.
Anyway, not quite the same league of single board computers as you were talking about, but if you want something with serious power in it, then small form factor, there it is.
Yeah, yep. All right, so this is the x86, and they have a... Where the other one is? They have their base model, and then this is the Ultra here. So the base model is closer to $100. This is the Advanced Plus here for $174. But here, so I have one here, and this one I've added a shield on it here. Oops, this is the shield. That's a bunch of little NeoPixel lights that I can control. So each one of these is a individually addressable RGB LED. Mm-hmm. Just for fun.
Yeah.
And I've also added the active heatsink on it here, which you can see it doesn't come with active heatsink by stock, just to keep it cool, because, that's what I like to do. And on the back side, you can see I've got the, this is the CMOS battery here that keep the real-time clock running and your CMOS settings correct while you lose power. And there are two antennas. So I have a Bluetooth antenna and a Wi-Fi antenna back here as well. And then this is the SSD drive. So
that's the M.2 style?
Exactly, M.2 style SSD drive. And underneath it, if you look at it, let's see. You can't really see it. Underneath is the M.3 Wi-Fi module, which you can't see from here. So it's got the M.2 SSD, and then underneath that is an M.3.
Is that M.2 or is that an SSD on a SATA? Because it doesn't look big enough to be M.2.
M.2.
It is?
Right there.
Okay.
And then the Wi-Fi module, let's see. Wi-Fi Bluetooth module is this guy here. Oh, he's M.2 as well. It's not M.3, it's M.2 Wi-Fi module.
Right.
So, and then it has, on here you can see we've got the, what are these? They're not, I guess Intel calls them light, or,
They're the Intel
DisplayPort.
Intel equivalent of Thunder blocks or whatever.
Thunderbolts, yes.
Yeah.
Your Mac calls them Thunderbolts. I guess Thunderbolts actually was an Intel standard, correct, that Mac just adopted, but no one else did. But This has the DisplayPort, Thunderport ports on it, HDMI port, Ethernet, and USB 3, and
those
power.
Those Thunder ports, aren't they basically just DisplayPort but smaller or different? sizes, different form factor.
They work as they are display ports with different form factor, but let me look and see which these are specifically to make sure I'm saying this correctly.
Because I'm pretty sure you can get in terms of copper wire, it's a straight a straight display port connection, and it's kind of frustrating that we've got so many variants of what is effectively the same standard.
So this has the Intel HD Graphics 400 video card integrated into it, and operating systems. Did I miss it? So it has 3 USB ports. Three. So on the back side we have 2 more here. Where's the? Okay, yep, they're mini DisplayPort plus
right.
connectors. That's what it is. So they're not Thunderbolts; they're DisplayPort. So it's just the mini DisplayPorts. That's with MacBooks they put both of them in together, so it can be either a Thunderbolt or a mini DisplayPort. These are mini DisplayPorts. So this can run 3 displays via that. So this one also has a. So this is the Intel Braswell CPU. Is this guy here? But then also, which you can't see because I have so much other stuff on here, it's got a second processor, which is the Intel Curie microcontroller, which is an Arduino compatible. So this is the same thing. This one will run the Arduino as well as the regular desktop type OS. So this one will run Windows 10 or Linux or Android. I know they have 3 OSs they support. I can't remember what the third one is. I think it must be Android. But I like this one for Linux personally, but it might work just fine with, or probably just as good for Windows 10 as well. So this one's more flexible than the other one, because this one here, I was able to get Linux running on this guy, but it was a pain. And the Wi-Fi wasn't compatible with Linux. You had to go through and change some BIOS settings, and then the BIOS settings made it so it didn't work with Windows 10 anymore, but it did work with Linux, but then the Wi-Fi didn't work, and so technically you can run Linux on this, but it's not as nice. This one here, beautiful Ubuntu installation, gets going on it just fine, or stock Windows 10. They have really good documentation on here on their website. They have videos that's like, hey, here's how you put the case together, which the case is just these acrylic boards with standoffs. And that's it. So this was really much simpler to put together than the LattePanda case, although it is a much more of a bare bones type case. I can pull this.
Still surprises me that we've got to the point that hardware is so inexpensive that it is more cost effective to put 2 different variants of processors on the same board. Yeah, there was a time it was cheaper to have your software engineers port the code to a different CPU.
Yep. So here we go. We see we've got the GPIO pins, and so the inside. So you got 2 rows here, 2 sets of 2 rows. The inside pins are the Arduino. The outside pins are the x86. So the inside pins are the Intel Curie. The outside pins are the Braswell, which is the full desktop computer.
Right.
So, question about what the project are, which Craig, you asked about this as well. So, I will be honest here, is I guess I'm kind of a collector. One of the things I like doing is just seeing how to make these work with Delphi. And so I've done webinars in the past and spoken at a couple of conferences. I need to do some more about this as well, just kind of showing what the okay, that was right. What you can do with them with Delphi. So I also have a webinar coming up here, I guess next week? It must be next week now, on my Linux cluster I have over here on how to build a Delphi application that runs on a Linux cluster. And I'm going with a different... So I discovered that clustering's kind of fallen out of favor as of late because of the... basically, so clustering is the idea of taking a bunch of inexpensive computers, if you will, and putting them together and making a supercomputer. But now, rigs like you have, Craig, where you have one computer that has a ton of GPUs on it, are now what people are going with for their supercomputer DIY or building up a supercomputer, modular supercomputer system, are based on kind of hardware you're doing, where people are able to, because that's become more prevalent. Yeah. So all the clustering software that is around it's deprecated, essentially. They're not updating it anymore. So it's like, is there any clustering software I can install in the latest version of Ubuntu? No. How about the latest long-term support version of Ubuntu? No. How about Red Hat? No. How about if I go back a couple versions? You're getting flaky at that point. So it's like, okay, so there's not any of these standard clustering solutions. So I'm looking at building my own clustering solution, of course, and see how that goes.
Give you a nod. Just if you put an SSH server on each of the boxes, then you can have a controller node SSH into each of the others to launch instructions. So that way you can distribute your job. You have an executable, and each of your nodes has the same executable. And you just SSH in, launch it, and tell it command line parameters. You're responsible for this part of the problem. That would be. I think that's effectively most of the clustering solutions that I was looking at about a decade ago had started going that way, where they were saying, well, we're not going to write our own controllers or load balancers or any of that stuff anymore. We're just going to write SSH tunneling based systems because that's the easiest way to do it.
And so that's what I do have, is I do have an SSH set up on each one of them. And then I mentioned last week I have a landscape so that I can push out updates to all of them as well. Which actually landscape you technically could use, because you could set it to run a script on all of them, and that script could go and grab the binary and run it on all the machines. But what I'm actually looking at doing is using something with app tethering.
Right.
And so having a system with app tethering where that I can have the app tethering program itself pull an update, right? So I have a main node, and it's going to say, hey, I've got a new version of this. And so then the individual ones could pull that out and then replace itself and then relaunch that new version of the application. Right, the new binary. And then it would run, and then it could they could all talk to each other on the network. So that tethering would have the advantage of auto-discovery as long as they're able to see each other on the network. And also, I was thinking I would add functionality in so that you could talk to the individual nodes with the resource management app tethering has built in, and say, hey, what is your architecture? What is your current utilization? And stuff like that. And so, because most clustering systems I've looked at are designed around the idea of all the systems being the same. All right.
Right.
And if they're not all the same, then they usually run at the lowest common denominator. So your slowest node in your cluster is really what's going to determine the behavior, the speed of the entire cluster. Yep. So what my thought is that by letting the nodes interrogate each other and see how fast they are, is that then I could say, hey, if you're faster than this node, then I'll give you more work than the other one is getting. Right. And the other thing I could do is then I could take these and put them in my cluster as well. Add them in. And so that will give them the ability to also behave in the cluster, and also it would work across different OSs, because Delphi the same application I build, right, could run on Windows and Linux and Mac OS and even Android technically. I guess you could do it on an iOS device. I have an iOS device I could throw in the cluster. I probably do. I'll throw an iPad in just for the heck of it. And they could all be, talking to each other.
Well, here's a little challenge for you then.
Okay.
Why not deploy a scripting language to each of them? And effectively what you would do is in your scripting language, you would say, okay, I've got this job to do. So launch, let's call them threads. They would actually be processes, but let's launch 15 threads and hand this work to each of these 15 threads. and then have your system behind the scenes go and determine which is the most available hardware for running these tasks, and light up a thread on there and run the script.
You can certainly do that,
So
yeah.
you have a programming. You see, one of the issues I'm facing right now with the GPU setup. So I've written this code which I've basically classified each of the devices that I can do processing on as a device or as an engine. Okay, and I can select, say, engine 0, which would be the CPU, and say, go do this job on it, and then select engine 1, which would be one of the GPU cores, go do this job on it, and just by switching which engine I'm using when I launch the job, it'll go run it on that piece of hardware. The problem I've got is I have these RX 580 graphics cards, which have 2 GPUs on the same graphics card. Each of those GPUs is 36 compute units. So I've actually got 70 odd compute units on that card with 8 gigabytes of RAM. But I have to keep, so that my task is isolated to 1 GPU currently. And what I'd like to be able to do is say, well, can I detect when 2 GPUs are on the same card, and because they are able to share the same memory resource, split the work up between the 2 GPUs. And I don't have that at the moment. So at the moment, if I run my simulation on a GPU, I can burn one core of the graphics card while the other one's sitting idle. Whereas it should be getting used because it's sharing the same memory, so therefore could work on the same task. But yeah, that's a challenge that I have to face, and I imagine the same challenge would be there on multi-core or multi-processor systems. So you'll have multiple processors with shared memory on one device. You have to make sure that the task gets divided up amongst the processors on that device. Yep.
Oh, yeah, that's a good point. So this is another board. I don't have one of these yet. Unless I said yet.
Yet.
It's the Orange Pi. So this is a company out of China. And they sell all their stuff through AliExpress is where their store is to buy all the parts. But they have a huge selection of models. And actually I made a spreadsheet up that compares them all. So I'll put that up online with this session on Delphi.org so you can take a look at it. But, man, their site's running really slow today. My Skype's using up all my CPU. That's because let me turn off my video screen sharing to you. So I was using Skype to send video. So that's how Craig and I talk, is through Skype. But I have my video on as well, so you can see the words I was showing. But now, I guess if I'm showing it on here, you can't see it. But anyway, that's a little better CPU utilization. Now Chrome's using all of it, of course. So anyway, the Orange Pis, these are ARM computers, ARM-based CPUs. They use ARM system on a chip, and they have almost all of them have a Android distribution designed for them. So these are great if you want to target Android on their Cortex A7 H3 quad core for this particular model. So if you want to build a small system that are Android based, these are start at $20. So I think this is what I ordered, is one of these Pi Zeros. Wow. So they're in China, so they're really slow web server. I'm guessing their web server is in China. Way back in my days of doing tech support, there was one motherboard company. I can't remember who it was, but they were out of Taiwan, and oh my goodness, their website was so slow. We used to joke that it was actually ran off of each page was on a different floppy disk, and people had to go. There was somebody there, and when you requested a page, they had to flick a floppy disk in to load up the next web page that you wanted. I mean, it was painful. This is fast compared to that. We were talking like 5 minutes to load a page.
What's wrong with us still hosting on 28.8 bps modems? Come on.
Yeah, exactly. So you can come in here. This one's less than $20 if I remember correctly. It's got an A7 quad core processor on it, and 10 megabit Ethernet and USB 2.0 and a Wi-Fi module for $20, if I remember correctly. So you go out to AliExpress where you can buy the boards. Yeah, $13 for this guy here.
Right. See, I'm always nervous ordering from China. I got a couple of parts for my rig from China, which, oh goodness me. So the case, the open air case that I bought from it was a Chinese vendor, but I don't think he'd manufactured it himself. I think he'd bought all the parts and put it together as a kit and resold it. But it came with these little, so it's basically standard maker, what do they call it? The little steel or aluminum bars. It's standard maker bar. It's what's used on most of the 3D printers. And it's effectively these little, I think it's steel, mine's probably aluminum, but it's these little bars with grooves on all four sides. And to attach them together, you use these little square nuts, because the square nuts fit into the groove and can't turn because they're square. The problem with these nuts was that whoever tap and dyed the threads through them, the standards were all off. And so I had all these little nuts that you couldn't actually screw in because the threads were broken. And I guess on some of them, and I think about 4 of them at the end, I basically started throwing the duff ones in a box. And at the end I had to force about 3 or 4 of them because I had none left. But it was really frustrating because the kit came with about 30% more of these nuts than it needed. And I think that's because they'd already determined that about 30% of them were going to be duff. It's like,
yep.
Great. And then the PCI razors. The PCI razors, these are renowned among cryptocurrency rig builders. These razors that, the solder joints on them are all done by hand, and the solder very often stands too far out of the board, and so it's very easy if you're putting them in adjacent slot or parallel slots to short them against each other. So you have to go inserting little slivers of plastic between them, plastic shims to keep them separate. I had a couple that, of the 6 I tried, 2 of the risers wouldn't actually fit in the PCI slot because the little notch that makes it fit in the slot correctly was in the wrong place. So yeah, $20. It's probably going to cost you $40 for that board because you're going to have to buy 2 of them to make sure you get one that works.
I've had so that's the thing. I buy a lot of stuff from China, and I was really hesitant as well. Boyan gets a lot of his parts that he does with the Arduino stuff from China via eBay, and I'm like, whoa, I'm not doing that because that's crazy land there. But it's kind of a little bit of a mixed bag. You can find a manufacturer that you like and make sure you're buying it from that manufacturer, and you can get consistency that way. But there are other manufacturers that, you get, you don't get what you order, or it's poor quality, or whatever. So it is mixed bag, for sure.
Actually, eBay may be an advantage, because very often what you'll find on eBay are people that are effectively distributors, and so they have found a manufacturer that they trust, and what you're getting is their selected components from China. So they've made sure they work when they come in. Sometimes. Yeah.
So I've ordered a couple of these. I can't remember which ones I ordered specifically, but see, this is probably one of their higher end boards here, and we see it's got a lot more I/O options on it. Still a 64-bit, 64. There we go. 2 gigs of memory. It's an ARM Core 7 64-bit. Probably not ARM Core 7. It might be an ARM Core 8 if it's 64-bit. A64 quad core. So it's quad core. I love how these are diagonal. Usually on boards you see them all parallel to the edges, but these have a couple diagonal chips on it, which I find really... There probably is an engineering reason. It's probably not purely done for aesthetic reasons, but I like it aesthetically.
Yeah, I can get on board with that. That's kind of pretty.
Yeah. So this has Bluetooth onboard microphone, GPIO pins here, etc. So lots of cool stuff here. So these guys, if you're wanting to get the BeagleBone Black is older, like I said, an older board. So it has KitKat as the Android that they provide for you. These are the newer ones. They just released at CES. Just released another new board. I can't remember which one it was. I can't remember if it was the One Plus or the Win Plus that they released at CES. Maybe it was the One Plus, but it only has 1 gig of RAM. Maybe they have a 2 gig version. Anyway, so take a look at these. Like I said, I'll put the spreadsheet up I put together that covers all the different boards and the differences between different boards and stuff, so you can see what the differences are on the Delphi.org. But I was just looking at the time; it's actually past top of the hour, Craig, and we didn't get a chance to get to the web stuff. So we were going to do Delphi on the web as well today, but didn't get to that.
All right,
next week.
You carried some great single board computer stuff.
Yeah.
Good collection.
Yeah. I have a huge collection of Arduinos, and I have another one. I have an x86 Arduino that's actually mounted over there. So it would probably run DOS, and it will run Windows CE, but then it also runs a special Linux for it that makes it a x86, makes it Arduino. So it's Arduino compatible, but it's x86. Right. And when I bought it, the site said runs Windows. I'm like, ooh, runs Windows. But it's not a. It's a specialized x86 CPU that does. It's 32-bit only. It's not 64-bit, so you can't run 64-bit Linux on it, which is the other thing I thought would be useful for. So it's an Arduino. I have lots of Arduinos. They're pretty cool. Actually, I got some really small ones. They're called Beetles. They're about that big. I'm wanting to make a smart 6-sided dice that you can roll. That's going to have Bluetooth and everything in it, but lots of fun projects. I have a box of fun projects that I hope to get to someday.
But I wanted to get to hardware projects, but time and financing to do these things is key. And software projects I can do. I have more time for software and more availability, more access to software than I do hardware. So I'm still focusing on software projects right now. I do have one hardware project that I really, really want to do this year if money permits, and that's that self-driving go-kart.
Oh, right, yeah.
So the catch with that is I actually would be looking for something along the lines of a single-board computer for that, but it needs to be able to run the neural net simulation. I don't need it to be able to train the simulation, just run it.
Right.
And so I need not necessarily as much grunt as for training, but I still need parallel processing and quite a large amount of it, because this thing's got to be able to run quick enough to give real-time decisions for driving the vehicle. Mm-hmm. So that's the one hardware project I'm hoping to get to, and I've got to find a suitable controller for. But software-wise,
what was that USB massively parallel system you mentioned last week?
So that was, and you looked it up, it was the Modius, I think it was. Basically a brain board. It's a neural net simulation chip. And that, I think, is maybe what I'm going to go for, because it's used. It's designed to be used on things like drones for vision processing, things like that. So potentially that's an option, but I still got to take a look at what the spec is and how I'd get it to run my simulation compatibility.
So it says it's compatible with TensorFlow and Caffe.
Yeah, and my own experiments are not using TensorFlow or Caffe. I've written my own neural net simulation library, which is working perfectly well. I'm quite pleased with what I've got. I didn't go for TensorFlow because TensorFlow is it's much better with NVIDIA, and I went for AMD.
Right.
And the only reason I didn't go to Caffe is because I haven't yet had a chance to play with it. I've been writing my own code for this, but I like So one of the advantages of AMD is it doesn't have as much throughput as the NVIDIA cards. So you end up buying twice as many if you want the same kind of throughput. However, what you do get with them is they support half precision floating points. And they can do twice as many half precision floating point operations as they can single precision for obvious reasons. So what you can actually get is close to NVIDIA performance on half precision. So my library is currently running single precision, but it can be switched between single, double, half, and extended. And so what I'm hoping to do is to increase its throughput by going to half, which I can only do on AMD. NVIDIA doesn't support half. So cutting all that short, and that's why I didn't go with TensorFlow or Caffe and wrote my own library.
So interestingly, I was just looking at this. It only works with where's that? Minimum system requirements, Ubuntu. So I'm guessing it's Linux only. It doesn't work with Windows. So you'll be running your control software on Ubuntu, which is fine.
Yeah, I mean, honestly, if I was, for a project like this, I'd want to build using Ubuntu or some variant of Linux anyway. Just for the sheer, I'm not gonna buy a Windows license to run on my self-driving car.
Yeah. Can make lots of jokes about that. All right.
Yeah.
Well, let's go ahead and wrap it up. Then we're 10 past.
Who wants a self-driving car that crashes all the time? Yeah.
There you go. You made the joke.
Yeah.
Okay. Well, very cool. Thank you, everybody, for joining us. And sorry, David was having some broadband issues and wasn't able to be online for everything here. But he was in the chat rooms apparently as well. And we'll see you all back next week. Thanks so much, everybody. Take care.
Thanks a lot. Bye-bye.